Hi everyone, welcome to my channel, and in this video I'm going to talk about a Linux boot process, and this is a part of the Linux Plus series which I'm making. I'm preparing for my Linux Plus, so I wanted to make a series. So today we are going to talk about a Linux boot process. And I just wanted to tell you that this Linux boot process concept is not just important for your Linux Plus or any other Linux certification, but it is also important if you give any job interviews related to Linux administrator, cloud administrator, security, networking. This is a fundamental concept to Linux. So you just need to know how the Linux boot process actually works. And in this video, I'm going to tell you all of that. So let's get started. There are basically three different parts, you can say, which happens in during the boot process. So the first part is BIOS or UEFI, which is a firmware. The second part is a bootloader, and the third part is the actual kernel or actual operating system. So we can divide it into many 5-6 parts also. You can watch any other YouTube videos, they must be dividing it in 5-6 different parts, but here I'm simplifying all of that. Let's start with the first one, which is BIOS/UEFI. What is the role of firmware in the boot process? Whenever you press power button in your PC, it will do a POST test, which is power on self test, which basically is a test for basic hardware components, that they are attached or not, like processor or motherboard or a memory, hard disk, is a basic check, you can say. Then this BIOS thing happens, and BIOS basically this post comes under the BIOS. BIOS basically checks basic hardware. So you can say all the network interface card, all the memories, all the disk partition, it checks it all. Then at this point, this BIOS should know that where to find the bootloader. And what happens with the BIOS is this BIOS runs this bootloader program. So BIOS must know where this bootloader actually is. And like most of the people, like we will boot from a hard disk drive or SSD. In a hard disk or solid state drive, whenever we install an operating system to a hard disk, that hard disk will be automatically divided in different partitions. And the first part of your disk, the first record of the disk, will be a master boot record, which is MBR. BIOS does not have enough memory to start the whole operating system or the entire operating system. So it happens in processes, like different processes. So BIOS will just check for the basic hardware. It will find the master boot record, and it should know that where this bootloader is. So these are the three jobs or a BIOS. UEFI basically is a new version of BIOS, which was released in 2005, and right now on all of our operating system we use this UEFI. So UEFI is basically an advanced version of that same BIOS thing. Instead of a single boot sector of hard disk like MBR, in BIOS we find MBR, right? But this UEFI has some different process, like it defines a special disk partition called EFI. So EFI will be your that special disk partition. And like you can find this EFI if you go to your operating system, your Linux operating system, in /boot/EFI, you will find a file called linux.efi. So linux.efi is the file, this EFI file. But here what we can do, that we can register individual bootloader files. So what we can do with that? Now, suppose we are using UEFI, right? And we are creating a dual boot system. Like we are running Windows also, we have installed Windows also, and we have installed Linux also in the same hardware. Right. In this UEFI, this can also boot Windows operating system. So what we have to do for that in this linux.efi file, we need to register the bootloader of Windows. So bootloader of Windows, we will register on this, and as soon as this UEFI will happen, it will find a bootloader for Windows. You can register both of them. You can set the priorities also. You can set the default as Linux, so it will boot Linux by default. If you don't do anything, don't select anything in the boot menu. And this UEFI also provides advanced boot menu, from where I will put two different like comparison between BIOS and UEFI on the screen, so you can see that UEFI is kind of like you have many options. You can change this file and UEFI file, and you can customize it. So UEFI will give you a lot of option, and currently almost in all systems we generally tend to use UEFI, but some older Linux system you will still find that BIOS thing running. So these BIOS and UEFI are just firmwares, and their job is to find the bootloader. So the bootloader is another very important concept in Linux boot process. So after this BIOS, that linux.efi file will have a path for our bootloader. So we have two kinds of bootloader. First one is Linux loader, which we call LILO. This is an older version, like before 1999. So this you can still find this thing in some of the older operating system, very old Linux systems, but generally we don't use it. And this we can use only with BIOS. So UEFI doesn't support this LILO. UEFI only supports grub, which is our new bootloader, which we use generally nowadays. We use grub, and in grub also now we have a grub version 2. So grub came in 1999 after this Lilo, and the second version of that was released in 2005. This basically changed your entire bootloader process. So what now will happen with this grub or this bootloader, that it will have an initial RAM disk, or we can say init RD. So this initial RAM disk, it will take that from memory, then it will load the kernel to it, and as soon as the kernel processes will start, this grub will leave that init RD, that initial RAM disk. That will this will unmount that, and the kernel will start. So the job of this bootloader is to load the kernel or load the kernel files. Kernel is basically actual files of our operating system. Grub is basically a bootloader, so it usually loads the kernel files into the memory. So this is just for that purpose. So your BIOS will have a path to the bootloader. That bootloader will have a path to the kernel files. So this is how your Linux system will boot up. Now this grub, this is an advanced configuration, so you have a lot of options. You can also go ahead in your Linux system and you can manually change the configuration of this grub, or you can manually also change you can, if you are using a grub, you can install the newest version, grub version 2. But be careful that these changes will be your fundamental to your boot process. So if you do any mistakes in this grub file or in this BIOS file or EFI file, that linux.efi file, if you delete something accidentally, then it will not able to find the bootloader. The bootloader will not able to find the kernel, and next time you will boot up your system, it will not work. So be careful while editing these files. I will provide a link to a document in the description which will tell you like how to install grub version 2 and how to edit these files. So you can basically go ahead and edit these files. And also I saw, like during my research, I saw one very interesting video. I forgot the channel name. I will put that video into the description. With that guy did like he created customized your boot menu, your customized boot process. I will recommend that video. You will watch that video and learn that how to configure these grub and grub2 files. So yeah, and if you want to know more about these, I will make a separate video about this, because there is a lot to learn in grub and grub2 also. For now, you just need to remember that this bootloader will eventually link to our kernel files. Kernel basically is our operating system. In init rd, that process will link up to many different processes. So sometimes we can set a program that whenever your PC boots up, that program will be loaded. So we need to change those settings, those configuration into these files. All the files which I discussed, you can change the configuration here. So now while doing my research, I created this, I'm creating my notes also while I'm studying. I will share all these notes. These will be publicly available to you after I end my whole certification journey. So here you can see, first thing is power on self-test, BIOS, UEFI, looks for a bootloader program. Then bootloader is your Linux loader or grub version 2. It determines which kernel program to load. Then kernel loads into memory and start necessary background checks. So this is how your Linux will boot up. There is a kernel ring buffer which will log the messages. The boot messages are copied into this kernel ring buffer. The command which we use to see this kernel ring buffer is dmesg, dmessage. And if you type this command, you can see all the Linux boot processes which will be recorded into this command. So you can see that, okay, this system MD started at 3 seconds and 0.280 milliseconds or something. 1 second, this all thing is happening. So basically from this command you will know that how the process actually starts, how the Linux is actually start. So if I can go to the top, maybe it will take some time. So I will, okay. What I can do, that I can copy this output to abc.txt. I can, no, okay. I can put this output to that and I can less abc.txt. Okay, so now we are at the top. Here you can see Linux version this, GUI ID this, then command line starts, then all this features, then this BIOS. See the BIOS, it maps the physical RAM. Then slowly it, like I'm using a VMware hypervisor, so it is detecting the hardware, underlying hardware, and then it is slowly starting the operating system from here. Like it is checking all the things, write back, uncacheable, write protect, everything it's checking, and then eventually it is checking all these things, and eventually it will start, like your processes will start, right? So hibernation, or you can type this command in your operating system and you will find how this boot process actually works. So this is a really important command, dmesg, dmessage. So please use that. This command is to view the boot message and troubleshoot the issue. If there are some issues, you can troubleshoot with this command. Then we also save, this Linux also saves your boot logs, and those logs will be saved at /var /log/boot.log, or under this /log there will be some other files, boot1.log, boot2.log, boot3.log. So there can be like many log files basically. So these will log your messages of your boot processes. You can see the bootloader, graph, firmware, everything. Like you can find these detail online. This is basically available for free. I will share these after I finish my Linux Plus course. Then like there can be two kind of failures while booting your Linux operating system. The first thing can be the kernel failure, and the second thing can be a root drive failure. So for kernel failure, basically when the Linux kernel stops running into memory, causing Linux system to crash, which is also known as kernel panic. So this kernel panic term is really important for your Linux Plus exam, and it can be fixed by editing the necessary file to change the system. So you need to edit the grub file to change, like to basically save from kernel failures or kernel panic. The second thing can be a root device failure. So your hardware, underlying hardware, it failed, that root device failed. So to rescue disk, you can use this command FSCK. This will examine the inode table along with the file block. So inode table is nothing but suppose you have 10 files, so this is an index. Inode is an index, so for these files. And if any error occurs, you will be prompted with a screen, and like do yes to that. And after completing this process several times, you can do this FSCK process several times, and eventually all those files which do not have any index or are lost inside your root drive, so that can be fixed by this command. So there can be these two kind of failures while your boot processes. I'm coming to the conclusion now. Like, the first thing is your BIOS, the second thing is your grub, and third thing is your kernel files. So firmware, bootloader, and the operating system. Understand this flow and this becomes very easy. And I'm following Linux Plus this book, this Linux Plus book. So please follow this book. This is like after watching my video, if you follow this book, so you will get a lot out of it, because I am also studying from this book only. So I would definitely recommend this book. This is like a very good book for learning Linux and preparing for this exam. So I hope that you find this video helpful in some way. So I will catch you in the next video with some CCNA concept or some networking or some general discussion or some Linux Plus videos. So please, I would recommend to subscribing to the channel. Yeah, I hope to see you in the next video, and take care. Have a good day. Bye.